The exercise related to the set 2 exercise related to DC electrical circuits. This exercise having MCQs as well as structure questions.
क्वेश्चन कराने लिखवाएंगे तो मान लो।
Question 39. You can use the chat to answer this question. Which of the following current potential difference graphs shows the correct behavior of a negative temperature coefficient thermistor? Thermistor is a semiconductor. So which one is representing a thermistor here? Which graph? You can use the chat to answer. So if we label these graphs, the first one, current and voltage are directly proportional. So this is representing ideal conductor. What about this one? Here the slope and the resistance are inversely proportional. Slope is decreasing, so it means the resistance is increasing. What does this represent? This represents a lamp, a filament bulb or a lamp. What about this one? It's not starting from origin, it start to conduct at a certain voltage. When start to conduct at a certain voltage, this is representing a semiconductor diode. So this is a diode. Where here the slope is increasing. If the slope is increasing, it means its resistance is decreasing. And for a thermistor, as we increase the voltage, it's a semiconductor. So for a thermistor, when we increase the voltage, its resistance will, because the current start to increase, more heat is there, or temperature start to increase, so its resistance start to decrease. So that's why option D is the right answer. Why do we say negative temperature coefficient? Negative temperature coefficient means like the relation between the temperature and resistance is inverse. So we call that as a negative temperature coefficient. Like if a temperature increase, its resistance will decrease. So the term negative temperature coefficient refers to the relation between a temperature and the resistance. So option D is a valid answer for this. A potential difference of a 6 volts is applied to a component to provide a current of a 3 amp for 2 minutes. In this time, the charge which will flow through the component. So we have the current is charge divided by time. So the charge which will flow, it is the current multiplied by time. So how much current is there? 3. The time is in minutes. Time should always be in second. So it will be 3 multiplied by 2, 6, and 6 multiplied by 6, 36, and then 0 will be there. So the total charge which will flow, that is 360 coulomb. In question 41, the EMF of alkaline cell marked 1.5 V is measured using a high resistance voltmeter and it is found to be 1.54. Explain why the voltmeter must have a high resistance. Usually, when they are providing us the cell, they're labeling the cell and giving us the exact potential what this cell can provide us. Like they're telling the terminal potential. If you're buying a cell, you will see that on the cell it is written 1.5 V. So what does it mean? It means that this cell can provide you 1.5 volts. Like if one coulomb of a charge will flow through a complete circuit, it will provide 1.5 joules. But when you connect a very high resistance voltmeter, so when we connect a very high resistance voltmeter, a voltmeter with a very high resistance, the reading on the voltmeter is not 1.5, it is a bit higher. It is 1.54. So how the voltmeter reading is higher than what is labeled? So what this give an indication that because when the voltmeter resistance is very high, no current will flow through this circuit. Because when a component is having a very high resistance, then there's no current in the circuit. If there's no current in the circuit, the current here will be zero, approximately zero. So if the current is zero, no potential across the internal resistance or no voltage drop internal resistance. So this voltage will be zero. So all the voltage of the EMF of the battery, if the EMF of the battery is 1.54 volts, the voltmeter readings will also be 1.4 volts. So why the voltmeter resistance to should be very high? How the current is zero? Because the resistance of this voltmeter is very high. If the resistance is very high, like example, if you're holding a cell in your hand, your body resistance is very high compared to the conduction of the flow of the charges. So we can say the current is zero. You don't feel it when you're holding a cell in your hand, you don't feel an electric shock. Why you don't feel an electric shock? Because your body resistance is very high, so there's no current able to flow through your body. So if the resistance of the component is very high, no current is flowing through the circuit. As a result, as no current is flowing through a circuit, no potential loss internally, and the reading on the voltmeter will be same as the EMF of the supply. So the EMF of the supply is equals to voltage drop external plus IR. But because the current is zero as a very high resistance external, so this factor is zero. So in that case, the EMF is equals to V. So what is the EMF of the supply? Same potential will be recorded by the voltmeter. So why the voltmeter must have a very high resistance? How you list those points? You will mention a voltmeter with a high resistance means no current or a negligible current. So no voltage drop internally, and the voltmeter reading is same as the EMF of the supply. Is it clear? So usually when they provide us the cell, these label 1.5 is actually not the EMF, it's the potential difference and external potential difference. The next is a student investigates the resistance of a lead in a pencil. A pencil is used to draw a triangle of a length 2 centimeter and a width of 6 millimeter on a paper, creating a strip of unknown thickness. So the thickness is unknown, this thickness is unknown, and the width is 6 millimeter, or we can say 6 into 10 to the power minus 3 meter, and the length is 0.02 meters. The resistance of the strip between A and B is measured. So because we measure the resistance in this dimension, because resistance of this dimension will be same as will be different from resistance in this dimension, because the length will be changed. So we measure the resistance from A to B. The resistance was found to be 55,000 ohm. So from A to B, the resistance is 55,000 ohms. The resistivity of the pencil is 3.5 exponent minus 5. Show that the area of a strip is about 1 exponent. We need the area. And area means the cross-sectional area. Let's say the current enter from here, so we need this area. This area is A. The length is 0.02 and the width is given 6 millimeter, like this dimension, this length, or you can also say this one is 6 millimeter, or 6 into 10 to the power minus 3 meters. So if you need the cross-sectional area, you'll use a formula that R is equals to rho L by A. You need A, so the cross-sectional area will be equals to rho L divided by R. where rho is a resistivity, that is 3.5 exponent minus 5. L is a length, which from A to B 0.02 and divided by 55,000. So what's the cross-sectional area of this? 3.5 exponent negative 5 times 0.02 divided by 55,000. So it is 1.3 exponent 11 and meter square. Is it clear how we worked out the cross-sectional area? What if in the same question they ask us to find the thickness? Like they ask us to find the thickness of this. So how we'll find the thickness? We know the length is 6 into 10 to the power minus 3 meter and the thickness is unknown. So area will be, it's a rectangle. So it will be length multiplied by width. So I'll not take 2. I'll take only this because we always, this cross-sectional area length I need. So this dimension was 6 into 10 to the power minus 3 and the thickness was unknown. So if I need this, so it will be 6 into 10 to the power minus 3 times t. I have the area, so I can find the thickness. If they ask, they did not ask for thickness. That's why I did not calculate. But what if they ask? So I'll use this dimension. So we always take the cross-sectional area through which the charges are entering the device or a component. The pencil lead is made of a mixture of a graphite and a clay. The purpose of the clay, because graphite and clay, clay is there to bind it as well as to make it smooth, like it can easily slide, reduces the friction. This pencil has 50% graphite and a 50% clay. The charge carrier density N for a pure graphite is 3.5 exponent 24 per meter cube. Calculate the drift velocity of the charge carriers in the pencil when the potential difference is 6 volts is applied across the strip A and B, and assume that the clay does not assume that the clay contribute no charge carriers. So this strip is made up of 50% graphite and 50% clay. The graphite is responsible for conduction, but the clay is not responsible for conduction, like it is not providing any charge carriers as insulator. So how we can work out the total number of, like the drift velocity. So to work out the drift velocity, we have the formula that the current through a conductor is equals to N, the charge density, number of charges in a unit volume, A, the cross-sectional area, V, the drift speed, and Q is the charge of one electron, which is a constant value, 1.6 exponent minus 19. So what is N here? Because in the question, they mention it is like 50% is there. So the total volume, 50% of the total volume will be the charge carriers. And here they mention that we have the charge density was 3.5 exponent 24. So how many charge carriers will be there in a 50? This is in 1 meter cube. So, but it's a mixture of a clay. So this charge density will be half. 50, because 50% will be the charge carrier and 50% will be the particle which are not carrying the charge. So the charge density, actual charge density will become half. So this will be 3.5 exponent 24 should be divided by 2. Why divided by 2? Because it's a 50% clay and 50% graphite. A is the cross-sectional area. which we calculated in the previous part. That was 1.3 into 10 to the power minus 11. V is a drift speed, we don't know, and Q is a charge of one electron. That is 1.6 into 10 to the power minus 19 coulomb. What about the current? How much current is there? The dimension, the potential which is applied across this, and the resistance of this section was 55. So we can identify how much current will flow because V equals IR. So if I need the current will be a ratio between voltage and resistance. So the voltage that is applied across this strip, 6 volts was applied. So 6 volts was applied. So we just put 6 here. And what about the resistance? The resistance was 55,000. Now you just solve for finding the drift speed, the speed at which these particles will move. So V is our subject. So it will be 6 times 2, that is the denominator, turn into numerator, and then these all will be denominator. So it will be 3.5 into 10 to the power 24 times 1.3 into 10 to the power minus 11, the area, times the charge of one electron, 1.6 into 10 to the power minus 19. That will give us the drift speed of the particles, the speed at which the particle will move through this. What's the final answer for the drift speed? 30.9 meters per second. Okay. So this is the speed at which these particles. Yeah, the 55,000 is also in denominator. I missed that part. 55,000 is also in denominator. 29.9. Okay. 29.9 now. So 29.9 meters per second. The next part, the pencil leads are made up with hardness range. You may have seen the labels are there on the pencils, like a 9H to 9B. 9H is very hard and 9B is very soft. Hard pencils have a greater proportion of the clay. Explain how the resistance of the strip would affect if it was drawn with a softer pencil. So if we draw with a softer pencil, so softer pencil will have a small proportion of the clay and it will have a greater proportion of the graphite. So as a result, what will happen? The resistance will be, because we want to compare the resistance. So there will be more charge carriers. If we have more charge carrier, in that case, like if the pencil leads are made from hardness range from 9H to 9B. 9B is very soft because it contains a greater proportion of a graphite. So how the resistance of a strip would be affected if it were drawn with a softer pencil. So if we use a softer pencil to draw this, as a result of a softer pencil, it will have a greater proportion of a graphite. More graphite means more charge carriers will be there, greater number of the charge carriers. As a result, the resistance will be lower. Is it clear? The last part? Question 43. An ampere can be expressed as, you can use the chat to answer. And regarding the MCQs, I have classified the MCQs from 2023 till from 2003 to 2023. So I will share that file also with you so you can practice these MCQs. So correct answer is for this one is A because current is the ratio between the charge and the time. I equals Q over T. Electrical power is transferred in a motor as shown. What is the efficiency of the motor? What is the efficiency? Efficiency is a useful power output divided by total power input multiplied by 100. So power output divided by power input. So D should be the right answer. A combination of a resistor is connected to a 12-volt supply and negligible internal resistance. The potential difference between A and B. So you can use a formula or you can use your understanding like because these two are connected in parallel. So the combined resistance when two identical resistors are in parallel, the combined resistance will be half. So means the combine of these two will be equals to 3 kilo ohm. So here I can solve that as well, like 1 over 6 plus 1 over 6 or product divided by sum for 2. As they're connected in parallel, 6 kilo ohm and 6 kilo ohm. So it will be product 6 into 6 divided by sum. But this product over a sum is only valid for two resistors which are connected in parallel. So 36 divided by 12. So it is equals to 3 kilo ohm. I did not use kilo suffix. Sorry, I mean prefix. So that's why this is 3 kilo ohm. Because the ratio of the resistance is 2 is to 1, so the ratio of the voltage should also be 2 is to 1. If the total is 12, so if it's 8 volts here, then it will be 4 volts across this one. So potential difference across A, B, so that should be C is the right answer. There will be 8 volts or it will have 8 volts across it. In question 46, the graph shows the potential difference characteristic of an electrical component. So what is this electrical component? This is a diode. This is a characteristic graph of a diode. Because the diode, as we have already discussed, the internal working of a diode, that the diode does not conduct at a certain, like it start to conduct at a certain voltage. Below that voltage, the barrier potential is high, so diode is not able to conduct. State the name of the component we call diode. State the resistance of the component at minus 0.7. So negative 0.7, this is a negative 0.7. So resistance is a ratio between voltage and current. So voltage is minus 0.7, but what is the current? 0. So if I divide anything by 0, what we get? We get infinity, like we're not able to define that answer. So we can say it has infinite resistance or it is having a very high resistance. You can say very large, infinite, infinity. You can draw the symbol. Calculate the resistance of a component when the potential is plus 7. Whenever you're calculating a resistance, you don't use a gradient for of current IV graph or reciprocal. It's just you take a specific value of the voltage because they ask for 0.7. So we'll draw a line from 0.7. And we find the current according to voltage is 0.7 and the current is 0.4. So 0.7 divided by 0.4 will get the resistance which is about 1.7 and the unit will be ohm. So 1.7 ohm is the resistance of this component. Next is state the practical use of this component. What is the purpose of the diode? Diode is used in rectification to rectify to convert AC to DC or to provide direct current to this component. It can also be used in indicator as well, power indicators. What is the meaning of the term rectify? The term rectify means when it is converting AC to DC, when it is converting AC to DC, we call rectification. This is a diode. When we connect this to an AC supply, left hand side is positive, right hand side is negative. So the diode, it's allow the current to pass, so the lamp will be on. So what cycle, if this is AC, this is AC supply. So one cycle pass through. But when the next cycle, because the AC supply, alternating supply, it changes its terminal. So as a result, positive and negative, the diode will block the current, does not allow it to flow, lamp will remain off as it's not a complete circuit. So diode block that current. So one way it allow, other way it blocks. So the output of a diode, allow, then block, allow, block, allow, block. What kind of current is this? This is known as the direct current or DC. AC current or alternating current, the current continuously changes its direction, like from it's from positive to negative, but the positive and negative changes. Next, we have electrically heated gloves are used by skiers and climbers to provide an extra warmth for their hands. Each glove of a heating element has a resistance of 3.6, two cells with an EMF of 1.5, and the internal resistance. So whenever a internal resistance is there, battery with internal resistance, that's how it is represented. When the switch S is closed, calculate the total resistance in this circuit. So if I close this, if we close the circuit, so this is the flow. They all are connected in series. So if all are connected in series we just add. So 3.6 plus zero point 0.2 plus zero point 0.2. So the total resistance will be 4 ohm, including the internal resistance as well, because the internal resistance will also take part in the applying a resistance in the circuit. Calculate the current in the heating element. The two are connected like this is positive, negative, positive, negative. So the total will be 3, the total voltage. So use a formula V is equals to IR. The total voltage of the circuit is 3. The the current is unknown. The resistance of the circuit, total resistance is 4. So it will be 3 by 4 or 0.75 ampere. So 0.75 ampere is the current which will flow through each component. Calculate the power output from heating element. So if you need the power output, here we have current, which is 0.75, and we have the resistance. So we can use a formula because we have resistance and current. So we can use a formula P equals I square R, where I is the current that will flow 0.75 square and multiply by the resistance, that is 3.6. So 0.75 divided by, 0.75 square multiplied by 3.6. That is equals to 2.02, so 2.02 watts. The next is when in use, internal resistance of each cell is gradually increasing. It increases. State and explain this will affect on the power of the heating element. In the question, they mentioned when we are using this circuit, the internal resistance has gradually increased. What will happen to the power output? So P is equals to I square R. When the internal resistance increased, like originally it was zero point 0.2, so the total resistance of the circuit was 4 ohm. But when these resistance values increases, the total resistance of a circuit will increase. If a total circuit resistance increase, so the current which will flow through the circuit, that current will decrease. And we have the formula P is equals to I square R. So if the current is decreasing, so the power output or power across this heating element will also decrease. So you can mention that the total resistance of a circuit will increase. So the current in the circuit will decrease. As a result, less power across the external resistor or the heating element. To the Is it clear? Or there is also another way if you want to write in terms of the potential or a voltage. Here internal resistance is increasing. So if the internal resistance is increasing, more voltage will drop internally. If more voltage drop internally, there will be less voltage external. And if we know the resistance, so we can use a formula P is equals to V square over R. R is constant because the voltage is decreasing, so the power will also decrease. So two ways are there to answer this question. One is you relate the current, resistance and power. The second is you relate the voltage, resistance and power. Like when the resistance of a circuit increases, like internal resistance increase, more potential or a voltage loss internally. If the more voltage loss internally, there will be less voltage external. When less external voltage, so for a constant resistance, for a fixed resistance, decreasing the voltage will reduce the power output as well. So these are some questions related to DC electricity.